Yeah, you have to revise the notes. That was your assignment. Okay. So let us begin with the session, since I think everybody is here. So to begin with, last time what we saw is that geometrical representation of vectors. So let me take a quick recap of that concept. So in geometrical representation of vectors, we saw that a vector is represented geometrically by drawing what we call a vector arrow. It is represented by drawing a vector arrow such that the arrow represents the vector is such that the length of the arrow is proportionate to the magnitude of the vector. So this symbol is used for magnitude. And this symbol here is understood as vector symbol for him. So it's vector here. The arrow on top of this represents a vector quantity. Okay. So whatever arrow that we are using to draw to represent the vector, length hai, that length is drawn such that it is perpendicular, it represents or it is proportionate to the magnitude of the vector. And the second thing is that the arrow head points along the direction of the vector. So the arrow consists of what we call an arrow head. This thing is called the arrow head. It points in a particular direction. So that becomes the direction in which the vector is acting. Whereas where the arrow starts from, this is called the tail of the vector, or it's called the origin of the vector. That one is called the head of the vector. So we saw that's how we represent vectors geometrically. Okay. Now, I don't think we had looked at any of the vector operations. Yeah, Shishir, I will send you the notes. Don't worry. Yeah, so the first operation we had seen last time was multiplication of a vector by a scalar. Okay. So, for example, we had seen that if suppose we are representing one vector with this arrow, this is vector E, and we say now draw the arrows for vectors B and C if B is equal to, let's say, 3 times A and C is equal to minus E by 2. So how we'll do this is we'll understand that when you multiply a vector with a number or a scalar, if that number or scalar is a positive quantity, then the direction of vector remains the same. So for example, here B is given to us as 3A. So 3 is a positive quantity. So it means that B is along the vector E. Or in other words, it is parallel to the vector E. And the magnitude of B should be equal to 3 times the magnitude of B. Hence, if A is being represented in my diagram as this arrow, then B in the same diagram would be represented by something that is 3 times its length. Such that B's magnitude is becoming 3 times B's magnitude. In short form, we just write this as magnitude of B. So that becomes the answer to the first part. Whereas the second part you can see is that since we are saying vector C is minus of E by 2. Okay, so basically we can say vector C is equal to minus of 0.5 times vector. So So we are multiplying with a negative quantity. So therefore, what will happen is that C is opposite in direction to E, or you can say it is anti-parallel. And of course, the magnitude of C will become 0.5 times the magnitude of, or E by 2. So once again now, because the vector E was like this, now in the same diagram we can represent vector C as something like this. And as we discussed last time, it doesn't matter whether we draw C here or we draw C here or we draw C here. We can draw it anywhere we like, but as long as it's the same thing, it's having the same magnitude and the same direction, it's always the same vector. Okay. So especially for some students who have recently joined in, you can just understand this particular question first. This particular example is the revision of what we learned in the first lecture. So this process is basically something like this, that B is equal to some n into A. Example like this. This is multiplication of a vector by a scalar. Okay. And of course, B is equal to n times A is as good as saying that A is equal to 1 by n times one and the same thing. No, for perpendicular we can't represent by multiplication with a scalar. Multiplication by a scalar बेटा के दो ही cases हो सकते हैं, या तो parallel या anti-parallel. Yeah, of course, the special case when that scalar quantity is 0, so it becomes a 0 vector or a null vector. Understood me? We cannot represent a perpendicular vector by multiplying a vector by some number. It has to be represented in a different way. Okay, we'll come to that. Okay. No, there's no such thing as negative vector. If we say minus of A, it just means it is minus 1 multiplied by E. So it is the vector which is, so this is the vector which is opposite to the vector E and of same magnitude. Okay. Hitanshu, you have attended all these things n number of times by now. Yeah? You understand all this. There's nothing not to understand. They are both facing in opposite direction, but yet they are parallel. नहीं देखो बेटा, एक का एरो अगर ऐसा है और दूसरे का एरो अगर ऐसा है opposite direction में, they are along parallel lines, but the arrows are in opposite directions. Then this is called anti-parallel. This is called anti-parallel. Whereas if the arrows are pointing along the same axis like this, then this is called parallel. No, a vector's magnitude cannot be negative. So, for example, if I ask you, what is the magnitude of minus A? It is the same thing as magnitude of A, which is the same thing as the length of that arrow. Length of a quantity cannot be negative, no? Similarly, magnitude of minus 2 times A is not going to be minus 2A, it's going to be 2A. Because it is, if this is A, then minus 2A is just this. So it has a length which is double compared to this length, whatever this length is. That's one. But the direction is opposite. So hope this is clear, people. Yeah, Karan, you will get the recording later. So if you were not able to hear because of internet connection or whatever, you can just see the recording later. It happens quite invariably that some point of time your internet connection might drop or something. So you might miss out some part of the lecture, but yeah. Later you can go through the recording and see whichever part you missed out. Okay. All right, now let's see another type of situation. Now in my next example, I'm involving the XY plane by drawing two perpendicular axes. This is the XY system. Now in this, I'm drawing a vector E like this, let's say over here. Which is making angle 30 degrees with the x-axis. Okay. I ask that now draw the following vectors. Okay. Approximately. Don't have to make an exact one. So E is, let's say, a force of 10 Newton magnitude. So it's a force which has magnitude of 10 newtons. Now we want to draw the following vectors. So we want to draw the vector B, which is a force of 5 newtons and perpendicular to E in the XY plane. And secondly, C, which is a force of 20 newtons at 60 degrees with respect to vector E. And again in the XY plane. And third is a vector D, which is of 10 newtons, but at 120 degrees with respect to the vector. So just try this in your notebooks, all of you, and I will make the diagram in just a couple of minutes, but try to get the diagram correct yourself. Then we will move on to the next vector operation. Yeah, only make the diagram yourself. So far, that's all I want in this. Okay, good. So I'm going to put up the diagram. So my original vector given to me was a vector E like this, which was of magnitude 10 newtons, and this angle was specified as 30 degrees. Now I have to make a vector B, which is perpendicular to E, and magnitude of B is, how much was it? 5 newtons. Yeah, 5 newtons. So यहाँ पे in the xy plane, how many such vectors are possible? There are 2 such vectors possible. One is it could be in this direction and perpendicular. So B could be like this, and about half the length of that one. So this could be B. That would be 5 newtons, and this angle you could see will become 60 degrees. Because, okay, or B could also be this one. So there are two possible vectors. Let me represent this with a different color so we don't get confused. So there are two possible vectors, let's say B and B prime, which have the same property, that they are 5 newtons in magnitude. So both B and B prime are perpendicular to A, okay, of 5 Newton magnitude and in the xy plane. ये angle तो 60 है ना बेटा, ये 9, this angle is 60. It is the same as this angle 60. Just the amount of the angle. What angle this line, this vector is making with respect to this line here is 60 degrees. Now likewise, now I want to draw the vector C, which is at 60 degrees with respect to A, and magnitude of C is 20 Newton. Okay. So that vector will look like what now? So just to unclutter the diagram, let me draw it beside here. So to give you reference, this was a vector E, suppose. So in comparison to this now, I want to draw a vector in the same plane, but which is making 60 degrees with respect to this. So that vector will now look like this. Either it could be like this. This could be the vector C. I am not drawing an exact one, so even this is 20 newtons. So ये angle 60 degrees होगा, तो ये इसके perpendicular हो जाएगा. Or it could also be this one. It could also be a vector like this. Like this. This angle will be 60. This is now. Oh, sorry. My mistake. That vector will look more like this. As how this angle should be 60 degrees, which means that this angle is only 30. So this could also be that vector. So both C and C prime have this property. No, you don't have to draw with measurement. That's why I said draw approximately, just so that we get an idea of how to represent vectors by the geometrical method. Okay. That's why in the question initially I told you that you just draw it approximately. Just approximate kind of drawing. Neither you have to take a protractor to draw the exact angles, nor do you need a scale or divider to make the exact measurement. Now similarly, how will the third vector look? Let's take a look at that now. So the third part of the question, we want it at 120 degrees, but of the same magnitude. So once again, let me start by showing the reference vector, which is E. So E is a force along this 30-degree line of 10 newtons magnitude. Now I want to draw another vector, let's say C, D, which is at 120 degrees with respect to E. And magnitude of D is 10 newtons and D is in the XY plane. So you can see that with respect to this one, I can either draw a clockwise or an anti-clockwise. So the anti-clockwise draw करूँगा ऐसा आएगा 120 degrees. be something like this, and should be of same length. So in fact, it will be something like this. Like this one. This is one possibility for the vector V. E all angle, as I was saying, it's an anti-clockwise angle of 120 degrees. So this angle will become 30. Okay. But this is of same length. Or I could also draw a vector from this side of 120 degrees. So इस side से अगर 120 draw करूँगा तो कैसा दिखेगा वो vector? That one will in fact look like this. That vector will now look like this. Let's say this is B prime. This is also that vector. So again, for each of these vectors, there are two possible solutions. So for each of the vectors that I asked you to draw, there are two different possibilities. Because you could have taken the angle in the clockwise sense or the anti-clockwise sense. Okay, so this is your basic part about geometrical representation of vectors. This is giving you an idea how to compare different vectors which are drawn geometrically. How, okay. Yeah, if I'm drawing in the xy plane, Malvika, then you can understand. ना यही दो vectors हो सकते हैं ना, और कोई vector तो हो नहीं सकता 120 degrees. अगर xy plane में नहीं है, then there are infinite number of vectors. Okay, then there are infinite number of possible vectors which are making an angle of 120 with E. Because then you are going outside the plane of the screen or the plane of the paper on which you are drawing. But within that plane, there are only two directions which are making 120 degrees with respect to P. Okay, but have you understood the point, Malvika? If you are restricted in a two-dimensional plane, okay, then there are only two possibilities for each angle. Right? Okay. Now let's move on to the next thing in vectors, where we'll understand addition of vectors. So next vector operation for us is addition of vectors, or what we call vector addition. To understand that this is a very different operation compared to scalar addition or compared to addition that you do in algebra. Okay. This is addition according to vector algebra, not according to the normal algebra of numbers that you use. So we'll understand this with a couple of examples first. So suppose I have a situation where, suppose S1 is a displacement of 30 kilometers towards east. Okay. And S2 is a displacement of 40 kilometers towards south. Okay. And we define the net displacement as the sum of S1 and S2. So this is now the net displacement, which equals to the other side, which is the sum of the displacements S1 and S2. So you want to find out the magnitude of this net displacement, how much this should be. So even though we haven't learned the principles of vector addition yet, कोई formula नहीं सीखा है, हमने कोई law नहीं सीखा है, but since these are displacements and we know the definition of displacements, we can do this operation by simple logic. Okay. So what is the definition of displacement? Definition of displacement is that it is the arrow, your straight line, whichever you call it, from the initial to final point. This is the definition of displacement. Very good. 50 meters will become the magnitude of 50 kilometers. Okay. So let's just use this definition. Okay. So using this definition, suppose I denote my geographical directions. I just assume कि मेरे diagram में ये direction east, ये direction north है, ये direction west है, ये direction south है. So then I should represent in the same diagram, I should represent the displacement S1 as, let us say, like this. Suppose I'm just using some arbitrary scale, but S1 is towards the east and it is 30 kilometers. Then how I will represent S2? I'll have to represent it like this, towards south, and will become longer. Let's say this is S2. This is 40 kilometers towards south. So now the point is, how do I calculate the net displacement? ये निकालना मुझे S1 plus S2. So how do I do this? So let's think logically. So क्या हो रहा है? Let's assume that I start from this point. This is my initial point O, and first I make the displacement S1. So S1, after completing the displacement S1, where I will reach? I will reach this point, which is whichever is the tail of the head of this arrow. So I will reach this point after completing the displacement S1, and that is supposed to be 30 kilometers towards the east direction. But then what is happening? I am adding S2. So after reaching this point, wherever it is, let's say this point is the point E, then I am making a further displacement in the downward direction or towards the south from E to this point. So I am reaching, let's say, this final point B after making a displacement S2, which is 40 kilometers towards the south. You can see my diagram represents this. It represents S1, which is O to P, that is 30 kilometers eastwards. And then S2 represents from the point A to B, which is a displacement of 40 kilometers to south. So now logically, what should be my net displacement? It should be from O to B. Na? It should be that one, because this is my final location, that was my initial location. So in this diagram, what is my net displacement? Logically, it is nothing but this. ये जो arrow है, वो मेरा net displacement. And luckily for us, even though I don't know any ready-made formula for vectors and all that, but just making use of the fact that this angle is 90 degrees, so I can see that the magnitude of the net displacement by Pythagoras theorem is just becoming square root of 30 square plus 40 square, that is 50 kilometers. So just by using the definition of displacement, and because we are little bit lucky over here, because we are given two displacements which are perpendicular to each other. So when we draw them, we are just having to solve something very simple. We are having to solve Pythagoras theorem or a right angle triangle geometrically. We are able to come up with a formula that is. So what this is telling us, that when A and B are perpendicular vectors, okay, then magnitude of A plus B automatically becomes what? It becomes root of A square plus B square. Okay, so this is a special case of a larger kind of operation, which is called vector addition. This is the special case when the angle between the two vectors is what? 90 degrees. When theta is equal to 90 degrees, you'll see always the resultant sum of two vectors has a magnitude which is given by root of A square plus B square, or in this case, root of S1 square plus S2. Okay. So hope all of you have understood this properly. I'll just give you a minute here to take down the whole question and understand this diagram and everything. Okay. So this is, we just do the vectors. The vectors S1 and S2. And next, from this now we will do the operation of S1 plus S2. Just by using that simple logic. Yeah, I'll give you time, but see, you don't need to write down the whole language of the question and all that. More important, just make sure you understand what's happening. And when I give you some question to solve yourself, that time make sure you solve it. Because I will be providing you with the notes, so don't worry. So just the solving part ना उसको आप अच्छे से समझ लो by doing this, making the diagram yourself, understanding how it is solved. But the exact details of the question and all that you can write in shorthand. You don't need to write exactly. Save some time. Concentrate on the understanding part. Don't worry about notes. तो आपको मिल जाएंगे. Rajit, initially you might find little bit difficulty with the model, but after you complete 2 or 3 lectures with me, you will find it easy enough to understand the model. Okay, just थोड़ा सा patience रखो, एक lecture और हो जाने दो after today, then you will understand. But exactly the point. Now we are that's exactly the point, Karan. Now we have to see that अगर वो angle 90 नहीं होता, then what we would have done. So let's see another example. Now suppose we have this case now that E is suppose a displacement of say 20 kilometers towards west. Okay. And B. Yes, Sushant, I will send you the notes of the first lecture. Don't worry. The notes and the video, both things I will send. Heron's formula. Interesting. You can tell me what that is. Now suppose B is a displacement of 50√2 kilometers towards northeast. That is 45 degrees north of east. So first of all, draw approximate vector arrows to represent A and B. And secondly, find the magnitude of A plus B in kilometers. Now you'll see that the second part is a little bit more challenging because they are not perpendicular vectors, but there is still some mathematics that you already know from 9-10, like trigonometry, Pythagoras Theorem, things like this that you already know. That you can same way we did the first question for the 2 perpendicular vectors, the same way we can logically understand what the sum here will become. So just try this out, give this a try. I'll put up the solution in a minute, but just try it out yourself. And the first part, too, definitely you should do yourself, that draw approximate arrows to represent the vector. Just try this out. So anybody got the answer? Yeah, what is the value coming? Yeah, थोड़ा सा strange type का value आएगा. Square root form में. Leave the answer in square root form. Yeah, that's fine. That's good. Okay. So let me start by drawing the diagram. So I can represent the first vector. Let's say 20 units. So ऐसा कुछ है suppose towards the west. So 20 kilometers towards west. So that is my vector E. So now my vector B will be in which direction? It will be northeast. So वो ऐसा हो जाएगा. It will be in this sort of a direction. This. But if I want to make it exactly, then something like this. Okay. In this direction. So this is 50 root 2, such that this angle is 40. Now that is the meaning of northeast. ये आपका east direction है, ये आपका north direction है. So ये इसको जो exactly split कर रहा है 45. That is the northeast direction. So it is 50 root 2. I will be giving a copy of the notes, Sushant. Don't worry. I will be. That's why I'm saying that just concentrate on learning the concept and doing the questions yourself. You don't need to write down the exact question details and all that, because all those things I will provide you with the PDF copy of these notes. Okay. So that during the lecture your concentration can be only fully on the learning part. Don't need to worry about all this. So anyway, so now what is my net displacement? मेरा net displacement यहाँ से ये point बनेगा. So this is where it becomes a little tricky. How will I use mathematics or geometry to find out this net displacement, which is E plus B? So मैं ये length कैसे निकालूँगा? So this is where my previous knowledge of geometry and trigonometry and things like that will come in little handy. So what I'll do here is that I will just drop a perpendicular here, so that I can construct two right angle triangles within this. Right. (80.2 raised to power 1/4. Let me check. The interesting value you got. So ये वाली लाइन को मैं extend कर देता हूँ, right? और ये वाले point से मैं इसके ऊपर एक perpendicular drop करता हूँ. So this is the added construction I'm doing, geometrical construction I'm doing this. So now see what is happening in this. Now see this side and this side are how much? So if you go to this triangle above, you can see that this side is going to be 50 kilometers. Right. And this is going to be 50 kilometers. How I know this? I know this from this triangle. I know this from this triangle. See, this is a triangle of, this is 50 root 2. This angle is 45. So this time. Okay, so now since this is 20, so this is how much impact. This should be 30. So my diagram is not that accurate. It should be actually longer than this, but anyway, so this is 30. Okay. So now look at this smaller triangle. So in this triangle, what is happening is this base is 30, and this perpendicular on this side, this is 50. Okay. So this hypotenuse, which is my E plus B, इसका magnitude कितना हो जाएगा? Like this. So E plus B is magnitude from root of 50 square plus 50 square. That is 10 into root of 5 square plus 3 square. 10 root 30. Okay. We can read the answer this way, magnitude of A plus B. Or we can do a bit of approximation. Whatever. So let me draw a more accurate diagram. So that we understand this even better. So if I try to scale the diagram more accurately, so suppose this is my vector B, which is 50 root 2 kilometers at 45 degrees. Then you would see here, I've drawn it exactly to scale in my figure actually. So I'm going to find it quite easy now. So मेरा vector A कितने boxes होते हैं? It's 50 root 2 ना. So this one would be just 2 boxes like this. This would be vector A, which is 20 in this direction. So my vector A plus B, which is the one I'm trying to find out, would be this. This would be A plus B. तो अब इसको निकालने के लिए मैंने क्या किया है, यहाँ से एक परपेंडिकुलर ड्रॉप कर दिया ऐसा, और इसको कंटिन्यू कर दिया ऐसा, so in this now, this side came out to be 30. This side came out to be 50. Because this was already 20. Just like so in this box, if I make a more exact kind of diagram, something like this, you don't need so much accuracy in the diagram as I told you, but this is just for demonstration. So ये side 50, ये side, right? So this is, okay. So finally we want to find this line. So we just understand that we break this figure like this. Alright, so that's how we are getting our mod of A plus B as that. Square root of 30 squared plus 50 squared, which is coming out to be 10 root 34 kilometers. Okay. Yeah, the angle between A and B, correct, Diti, is 135 here. That's correct. The angle between A and B will be 135 degrees. Okay. So people hope you understood this example. If we connect both, then there is a method. Okay, we can do that also. But देखो यहाँ पे Karan, what you have to understand is हम उनको head to tail ऐसा क्यों draw कर रहे हैं? Because we are interpreting it as displacement, ना? So our logic is that only, that if A is a displacement towards the west and then B is the displacement towards northeast, so how are we actually moving? Na? We are first moving towards the west, then from where our A displacement is over, from that point we are making our displacement B, which is going towards the northeast. So that is the logical reason why we are drawing the vectors in what manner? We are drawing them one after the other, or what we call in vector language, the vectors are drawn head to tail, right? So now what we will do next is we will make a, if we join both the vectors tails, then also we can solve, but that's a different method. Okay, So we'll come to that later, but I'm just saying that what is the logic of the method that I have given you here. The logic is very simple. It is the definition of displacement, है ना? So मैं अपने starting point से पहले ऐसे जा रहा हूँ, फिर वहाँ से ऐसे जा रहा हूँ ना. So that is the reason why I'm drawing the vectors head to tail to calculate the net displacement. Okay. Yeah, there might be a way of drawing the vectors tail to tail and calculating the sum also, and we'll come to that. That is called parallelism law. But first, let us understand this. And officially now, we are going to develop the formula for calculating vector sum by using something called triangle law. Yeah, meet the 50 wala side देखो क्या हो रहा है. Within this diagram, now you have two triangles. So if you just see within this diagram, okay, so let me just give me a second. So I'll just explain the point again. Don't worry. So within the diagram, I have two triangles. One is, you concentrate on this triangle which I'm going to shade now. Okay. This triangle. This triangle. See. This is which type of triangle? This is an isosceles right angle triangle. है ना? जिसका कि hypotenuse कितना है? 50√2. So sides कितने हो जाएंगे? 50. So that's why this side above is 50 and this side below is 50. Understood, Nameed? Right, so that's the first triangle. Now from that we are also understanding this next triangle which I'm going to shade. Now this triangle, see. This one. This is what type of triangle? This is just a right angle triangle. This is a right angle triangle. इसका कि ये वाला side कितना है? 50 है. But ये side हमने कैसे निकाला? So that is how we got this. That we saw that this was 50 and this is 20 because the magnitude of A is 20. So here to here has to be how much? This has to be 50. This total length has to be 50. So that's how we know that this is 30. Okay, so now we know that in this triangle, the second one that I've shaded, जिसका कि hypotenuse क्या है? ये वाले triangle का hypotenuse is the magnitude of A plus B. Okay. And the base is how much? It is 30. And the perpendicular is how much? 50. So substitute that and from that we know. So you can't join tail to tail, na beta, because उसमें logic ही नहीं है ना. You're doing the sum of two displacements. So how you can join tail to tail? You understanding? Kunal, why we have to join head to tail like this? Na? Because we are making displacements. Got it? Understood? Okay. All right. So now let us develop a formula for the general case like this. Okay. So now we will develop what is called triangle law for addition of two vectors. Any two vectors which you want to add, whether they are two force vectors or they are two displacement vectors, anything, we can find. Yeah, that is good, but that is independent of this. No? So now pay attention to this next thing. Okay. So whether we are adding two displacements or two forces or two velocities or whatever, yes, stage that you have learned in the last lecture, na, to find the angle between two vectors, you have to join them tail to tail, correct? उसमें क्या problem है? But that is apart from what we are doing. Na? Here we are doing the addition of two vectors. Okay. So this is that given the magnitude of the vector E, okay, magnitude of the vector B, and the angle between them, that is angle between A and B. Okay. We want to find A plus B. Okay. This is called the resultant, okay, or it is called the sum of A and B. Okay. It's called the resultant. So whenever we use the term resultant of two vectors, we mean the sum of the two vectors. Okay. So how to find this? That is the principle of triangle law. So what we do in triangle law is, suppose we know that this is the vector E, and we know this is the vector B. So I know that the angle between A and B in this diagram will be which angle? It will be this one. We can see the same two vectors, if I draw them from the same origin, A is in this sort of direction, B would be in this sort of direction. So the angle between A and B is this angle theta. So the same theta I have labeled over here. Okay. So now how to find A plus B? So A plus B is calculated by doing this, constructing a vector triangle, okay, such that vectors A and B are two consecutive sides, okay, such that they are drawn head to tail. So this is just like the example of displacement. So पहला step मुझे क्या करना है? I have to construct a vector triangle such that ये जो vector A था उसको और जो दूसरा vector B था उसको हमने ऐसा construct किया as the consecutive sides of some triangle such that they are drawn head to tail, one after the other. So this was the vector A, this was the vector B. So the angle between them becomes this. So if this is a displacement and this is the second displacement, now you can see the third side of the triangle, which is this one, will become the resultant displacement. So this becomes the resultant displacement, and this angle is suppose alpha. So now what happens is, so the third side, okay, that is the vector from the origin or tail of E to the head of E. Okay. So that third side represents the sum A plus B, okay, or what we're calling as the resultant. So the moment we construct this triangle, so this is basically the same thing that we did for displacements. Now we are saying we can do for any two vectors which we add in. So what we have to do is we have to place the vector A, and then from the head of the vector A we have to draw the vector B. So they will form two sides of two consecutive sides of a triangle. So we draw the vector A, फिर उसके head से दूसरा vector we draw करते हैं, and then the third side of the triangle that they are forming, which is from the origin of the vector A to the head of the vector B. ये वाला जो vector होगा, from origin of A to the head of vector B, this one, this will represent the resultant sum. Okay. So now the question becomes how to find, now given the magnitude of vector A, the magnitude of vector B, and the angle theta, we want to find two things: the magnitude of A plus B. Okay, so this is nothing but magnitude of the resultant, and we also want to find out alpha in that diagram, that is the angle of the resultant E plus B, okay, with respect to E. Okay, so that angle will give us direction. So when I say find a vector, I need to find out both things, the magnitude and direction. So just finding the length of the third side is not enough. I need to find out what direction it is at also. So we need to find out both these things, provided we know the two sides A and B, and we know this exterior angle theta. So now how do we do that? So let's see the next part of the derivation. Okay. So the next part of the derivation is basically what we had done numerically in that question. Now we are just going to do it parametrically. So A and B we have constructed like this, head to tail, and this angle here is theta, and we are seeing that the resultant sum of A and B is becoming the third side, which is this. So we want to find the third side of this triangle, given that we know that this side's length is capital A, this side's length is capital B, and this exterior angle is theta. So we do the same kind of construction that we done earlier. We continue this line forward, we drop a perpendicular from this, and first we have this right angle triangle, this one, in which this side is, let us say, x, and this side is, let us say, y. So this triangle when you look at it separately, ये कैसा दिख रहा है? Triangle like this. This side is B, this side is y, this side is x, and this angle is theta. So this is the same triangle which I have just removed out from that diagram so that you can concentrate on this triangle. So in this triangle, now we can see that here cos theta is how much? It is base upon hypotenuse. So here theta is known to me. Remember, A is known to me, B is known to me, theta is known to me. So cos theta is known because theta is known. So x कितना हो जाएगा? B cos theta. So that's equation 1. Okay. And similarly, in that triangle, sin theta is perpendicular upon hypotenuse. So here y is the unknown, theta and b are known. So what is that unknown quantity? It becomes b sin theta. That becomes the second. Okay. So just write down these steps, or make sure you understand these steps. Even if you don't write in detail, just make sure you understand these steps first. Okay. Then we will come to the next part: how to calculate the hypotenuse, or how to find out a plus b. So in fact, start from here so that you understand what we are doing first. Okay. So given two vectors such that we know their magnitudes and we know the angle between them, we want to find out the resultant. So in other words, we are given these two vectors drawn as arrows. We know the length of the arrows, we know the angle between them. So how to construct a plus b? So we start by constructing a vector triangle such that a and b are the consecutive sides of the triangle drawn head to tail. So from these two vectors given to me, now I have constructed this triangle. I have first drawn, so this vector a I have drawn it, and then from the head of a I have constructed this vector b. So this vector has been drawn. So the third side of the triangle, which is from the tail of A to the head of B, that third side automatically becomes the sum. It becomes the resultant. So that's the construction of the vector triangle. Now obviously मैं बैठ के यहाँ पे geometrically ये length measure करके नहीं करने वाला हूँ. I'm going to solve this using trigonometry. So how do I find the third side of the triangle? Just by using trigonometry. So for that, this is what I do. First, I drop a perpendicular from this onto this line, and I solve this smaller triangle. So in this smaller triangle, if the perpendicular and the base are x and y, x comes out to be b cos theta, y comes out to be b sin theta. Okay. So make sure this step is clear to all of you. The solution of this smaller triangle, this one. Now let us come to, within the same diagram, let us understand how to solve for the unknown quantities, which are magnitude of a plus b and the angle it is making. Okay, so within that same diagram, now next up what I will do is, I want to find out this thing, ye kitna hai, and I want to find out this angle. But for that, yes, very good, that's correct. So you just have to use Pythagoras theorem once more. I saw that this was y, this was x, and this was a. So now what is happening is, if you look at this larger triangle now, this whole triangle, this one, this whole right angle triangle, in this base is how much? It is a plus x. This is the base of the triangle, and this is nothing but the perpendicular of the triangle, or this is the height of the triangle. So this becomes what now? This becomes the hypotenuse. Okay. So the hypotenuse, which is magnitude of that resultant, is just becoming the base, which is a plus x ka square plus the perpendicular ka square, like this. Okay. So this is my third equation. Now go back to equation 1 and 2 and substitute the values. Okay. So magnitude of the resultant, which you can also call as magnitude of a plus b. So from equation 1 and 2, x was how much? X was b cos theta. And y was how much? It was b sin theta. So isko substitute kar. And then you just apply normal principles of algebra. So a square plus b square plus 2ab cos theta plus b square sin square theta. Now you remember that you have the identity. Yeah, which part, Sushan? Okay. So see here, you're looking at this right angle triangle ना, ये वाला part यहाँ से यहाँ तक कितना है? A है ना, और फिर यहाँ से यहाँ कितना है? X है. So ये total base कितना हो गया? A plus X, और ये perpendicular कितना हो गया? Y. So you're just using Pythagoras theorem ना, that the hypotenuse is equal to base square plus height square. So let's just substitute. Now earlier in equation 1 and 2, you had seen that x is b cos theta and y is b sin theta. So you're substituting these from equation 1. Okay, from here to here, you're substituting from equation 1 and 2 the value of x, which is b cos theta, and the value of y, which is b sin theta. Right? And then I'm just expanding using the whole square formula. So that becomes this. Okay, now since you know that sin square theta plus cos square theta is unity. Okay. So use that. So mod of a plus b is becoming root of a square plus b square if you take common. So you have cos square theta plus sin square theta. So this whole thing will become unity, and then that 2ab cos theta term will remain. So magnitude of a plus b is, now we have a ready-made formula. So from this point onwards, whenever we know a, b and theta, we can just substitute in this formula and get the magnitude of a plus b. We don't need to construct the triangle. We don't need to do all this. We can just directly substitute in the formula. So this is the first part of the triangle law. Yeah, Tej, tell me, what is the doubt with that? This is the triangle law. Formula number 1. Yes, this becomes a formula, Rachel. Yeah, Tej, what is the doubt? Tell me, beta. नहीं, कुछ गलत किया होगा आपने बेटा, आपने एंगल गलत यूज किया होगा, एंगल 135 यूज करना है, not 45 degrees. Okay, I'll do that some later by this method also. So you'll have to use, so a lot of things we have to learn actually, how to calculate sine and cos for obtuse angles, you know? So I'll explain those things, don't worry. So this is the first formula of triangle law. Now remember, we also need to calculate one more thing, and that is this angle. ये वाला angle alpha भी निकालना है. Okay, so we have to also calculate, not only we need to calculate the magnitude of r, which we have done below, we also have to calculate alpha. So I'm coming to that, but just first make sure you understand this part. Okay? So I'm actually going back to equation 1 and 2 first. Okay, so see the whole thing in detail now. So first, we calculate the value of this x and y for this smaller right angle triangle. In the same shape, we have actually constructed two right angle triangles. Yes, Yash, I will explain to you how to solve when we have obtuse angles. Yes, Diti beta, what is your question? I think I missed your question. If the line of the resultant is drawn in between the two vectors, in between कैसे जाएगा बेटा? See, subtraction is a different operation. We'll come to subtraction. First, concentrate on what we're learning here, which is the sum. See, Diti, you can only have two situations. One is when A and B are having an acute angle, so the resultant is like this. Or one is when A and B are having an obtuse angle, and the resultant is like this. So they will always form a triangle. The only case where it will not form a triangle is like this. If A is like this and then B is like this, then they don't form a triangle. Or if A is like this and B is in the opposite direction, then again they don't form a triangle. But in that case, it's anyway very easy to calculate now, the sum and the difference, the sum of the vectors. Okay. So other than when the angle is 0 or 180 degrees, other than when theta is 0 or 180 degrees, they will always form two consecutive sides of a triangle. A and B, when you draw them head to tail, they will always form two consecutive sides of the triangle. And the third side will therefore become the sum. Hope that clears your doubt better. Yeah, Diti, is it clear? Okay. Okay. As we do more questions, आपको और clarity आएगा. Don't worry. When we take some values and all that, we will get understand this even better. So don't worry, we'll be solving n number of problems using vector addition and all that. So this is just the beginning. It's just, you can say that we're getting familiar. Your operation hota kya hai, na? What is the meaning of addition of two vectors? We're just beginning to understand that right now. Okay, so this part is just algebra. So you don't need to memorize the algebra. You just need to understand ki kaise hota hai. What you need to memorize is the final formula, that root of a square plus b square plus 2ab cos theta, that formula. Okay, so using that trigonometric identity, sine square theta plus cos square theta is unity, we finally come up to this formula, and this final formula is the one which you need to remember, because we'll be applying this directly in questions. Okay, so is it clear up to the formula? Yes, people? Okay, good. Okay, so let me now come back to the diagram, and now let's talk about alpha. So how will we calculate alpha? Okay, so this part. So for that, you can see in this triangle, tan alpha is height upon base. Okay. So tan alpha कितना हो जा रहा है? That is y upon e plus x. Okay. Alright. So y is how much? It is b sine theta, and x is how much? It is b cos theta. So we have the formula that tan alpha is equal to b sine theta upon a plus b cos theta. So this becomes the formula for finding the angle alpha. यहाँ से alpha आ जाता है, ठीक है? So that is the second part of the triangle law formula. The second part of the triangle law formula along with this is that tan alpha is equal to b sine theta upon a plus b cos theta. So formula 1 gives us the magnitude of the resultant, and the second formula gives us the direction, or it gives us the angle it is making. So from that we know the direction. So this is triangle law formula number 2. Now, so collectively these two, they are called the triangle law, okay, for sum of two vectors. Okay, people. So let us solve a couple of simple problems using this. Achha, first you just go through this thing first. Calculation of tan alpha, how we did. Okay. So again, see, this is written in reference to this diagram, this right angle triangle. So again, in the larger triangle, the shaded one, yes, we can sum n number of vectors also, and we will see that once you are clear with the applications of triangle law, we can see how we can sum more than two vectors also. And obviously, Kunal, I can make any number of displacements one after the other, or I could be applying 10 or 15 different forces on a particle, but I have to calculate the net force, which is the sum of that. So there's no restriction on the number of vectors we need to add. There can be any number of vectors, because after all, remember one thing, that whatever we are learning in vector algebra is not just for the sake of the maths of it, it's for application in physics. इसका purpose तो वही है कि हम इसको physics में use करेंगे. Like when we come to Newton's laws of motion, we will see that to calculate the net force on a body from which we can find out its acceleration, we need to add the vectors. Forces are vectors. So if there are 5 different forces acting on a body, then we need to do the vector sum of those 5 different forces to find out the net force. Only then we can find the acceleration. No. Or any such situation, we'll see later that. Okay, so now let's do a couple of examples. So magnitude of the vector E, let us say, let me start with something simple. Magnitude of the vector E is 10 units. Magnitude of the vector B is also 10 units. Okay. And the angle theta is 60 degrees, okay, for the vector B with respect to vector E. So you want to find magnitude of A plus B, okay, and the angle made by the vector A plus B with respect to the vector E. That angle is suppose alpha. You want to find that. Okay. So we will first do this problem by formula without doing any construction. Okay. So what we do is, by formula method, and secondly, we will justify the result geometrically. So second part जो हम करेंगे, that is only for our satisfaction. The solution of the problem is done in the first part by formula based method. Yes, that's correct. Diti, very good. The answer is correct. Yes, Tej, that's correct. Yancy, correct. Very good. Both the angle and this thing are both correct. Very good. So you people are getting it yourself. So I'm just leaving you with some more time. Okay. So all of you get it. So Tej, Yancy, and Diti, all three of you got the correct answer. Tej and Diti also tell me the angle. Yes, correct. So Karan, Sagar, Yash, तूने कुछ गड़बड़ किया है. Rest of you got it correct. Mahima, Tej, again Tej, your angle is not correct. Check once. Okay, so let me do by the formula based method first. So the formula based method में magnitude of a plus b is root of a square plus b square plus 2ab cos theta में मैं a को सब्स्टिट्यूट करूंगा 10, b को सब्स्टिट्यूट करूंगा 10, theta को 60 डिग्री, so cos theta will become half. All of you know cos 60 is half, so this becomes square root of 10 square plus 10 square plus 2 into 10 into 10 into half. So as you can see, it becomes square root of 100 plus 100 plus 100, or root of 300, or that can be written as 10 root 3, or approximately 17.32. Whatever, but this is okay for the answer. Here I am taking root 3 as approximately 1.73. So it's an irrational number. So actually, there's a non-terminating decimal, as you know. So ये मेरा magnitude of a plus b होता है. Okay, so this is the first part of the thing. The next, tan alpha is equal to b sin theta upon a plus b cos theta. So you can see that sin theta will become root 3 by 2 plus sin 60. So you should remember these values. Standard angles के sin cos tan आपको याद रखने के लिए. So this is 10 into root 3 by 2, the numerator, divided by 10 plus 10 into half. So I can just write that as root 3 by 2 divided by 1 plus half. So that is root 3 by 2 divided by 3 by 2. So that is root 3 by 3, which is 1 by root 3. Okay. So you can see that tan alpha is 1 by root 3. So that you know again that standard value, it is 30 degrees. So this becomes the answer for the two things by the formula based method. Now, it's pretty straightforward. इसमें कुछ नहीं करना है. You have to just substitute the values, and like I've done, patiently you do the steps properly so that you don't make any mistake. The only difficulty with this mistake is with this method is if you make a mistake in any of the steps. The rest, इसमें you don't have to apply anything else. Yeah, this is only the formula. This is the only formula we have for adding two vectors when the angle between them is known. Okay. So now let's also understand this geometrically. So geometrically, we want to try and understand how this is happening. So we'll see that the geometrical construction of my vector triangle will look something like this. Approximately, I'm saying something like this. And this angle has to be 60 degrees. This is also 10, this is also 10, because both the vectors are having the same magnitude. Okay. And now this vector here is the resultant, which is E plus 1. Now, and this angle is alpha. Now notice something here, that the vector triangle is an isosceles triangle. Okay. So we can make use of the following properties of isosceles triangle, and those properties are the following. If this side is equal to this side, and they are both, suppose, x in length, or let's say they are some a in length, then this angle will become equal to this angle. Okay. And the sum of those two angles will be equal to the opposite exterior angle. So alpha will be equal to theta by 2. So in this case, alpha becomes 60 degrees because theta was 60 degrees and that small a was 10. So that's justified. We had got by the formula method also earlier. Okay, then the other property that we can use of isosceles triangle is that from the vertex of the equal sides where they are matching, if we drop a perpendicular, it bisects the triangle. So we can make use of this property. So if we drop this perpendicular, it bisects the triangle. So that means this side, suppose it is x. This side will also be x. Okay. And now if you look in any of these two triangles, the smaller triangle for example, you will see that cos alpha is based upon hypotenuse. So that x is becoming a cos alpha. So it is becoming 10 cos 30. So that is 10 into root 3 by 2 or 5 root. So x is becoming this. So now this thing, which is our resultant's magnitude, is 2x. Oh, sorry, yeah, alpha would be, yeah, my mistake, guys. Thanks for pointing that out. Alpha is 30 degrees, rooted 60 by mistake. So this should be 30 degrees, and यहाँ पर भी 30 degrees substitute there. All right, so the resultant's magnitude is 2x or 10. Okay. So you can see here that this is magnitude of a plus b becoming 10 root 3 units, and alpha is 30 degrees. So that is justified geometrically that we got from the formula based method earlier. यहाँ पे हमने क्या trick use किया, because the magnitude of the vector a and b was both 10, so we could use the trick of solving an isosceles triangle. It's not always that tricks like this will happen, but so it's like formula based method is always there. It's like the brute force method. If nothing else is coming to mind, you can just substitute in the formula and do the computation like a program would write it, like a computer program would do. It would just churn the numbers. तो वैसे आप formula use कर सकते हैं. But sometimes if you look at the values and visualize the triangle, you can see that there is a more elegant solution to it, a more pleasing kind of solution, because there is some symmetry or there's some geometrical trick that you can use. So okay, people, so hope this is clear. Okay, so let's come to our next question. So this time we have this equation that A is of magnitude, let's say 20 units, and B is of magnitude 60 root 2 units. Okay. And the angle between them is 45 degrees. This is the angle between A and B. Okay. So you want to find the resultant's magnitude and the angle of the resultant with respect to E. ये दोनों चीजें अपने को निकालनी. So in terms of language, what it means, resultant's magnitude is mod R, that is mod of E plus B. This we want to find. statement is this. Now I have not specified which method you have to use, so it's up to you. आपको जो method अच्छा लगता है, whether you want to construct geometrically the triangle and try to figure out from the geometry how much it will be, or you want to just blindly substitute in the formula. It's up to you, but you have to give me the answer how much it is. Yes, very good. Yes, that's correct. Yes, stage, that's correct. Good. Okay, it's fine. I will admit you into the class after you rejoin. Okay, no problem. Yes, Sweta, that's correct. Very good. So, Tej, Sweta, Yash, all of you use the formula method or the no, Idanshu, the answer is not correct, unfortunately. Diti, correct. So you people have used the formula based method or the okay. So now try it geometrically also. If while you're waiting for the others to confirm, just try to draw the triangle and justify your answer also. Current, unfortunately, no. Okay, so let me first solve it by the formula based method. So by the formula method, okay, the magnitude of a plus b will become the root of a square plus b square. So that was 60 root 2, correct, plus 2ab. So 2 into 20 into 60 root 2 cos theta. So that's cos 45 degrees. So it will be like this. So let's solve this. So this is 400 plus 7200 plus 2 into 20 into 60 root 2 into 1 by root 2. Cos 45's value, you know. Yes, 1 by root 2. Okay. So 400 plus 7200 plus ये कितना हो जाएगा, root 2 will cancel, so 24. Okay. So you can take 100 common from all of this, so you have 4 plus 72 plus 24, which will give you another 100. Okay. So 10 root 100, so that will become 100. Okay. So 100 units becomes the magnitude of a plus b. Okay. Now the angle will be a little challenging here for us to calculate. So plus, along with this, we have to also see that tan alpha is b sine theta. So that is 60 root 2 sine 45 upon a plus b. So that is 20 plus 60 root 2 cos 45 degrees. Correct. Yes, very good. Yes, that's correct for the angle. So it is 60 root 2 into 1 by root 2, correct, divided by 20 plus 60 root 2 into again 1 by root 2. So I mean, there's nothing difficult in this. Just mechanically, I'm doing the problem. It's not a big deal. So that is 60 by 80 or 3 by 4. So now at this stage we may not know what angle this is. So tan alpha is 3 by 4 or 0.75. So we will, or we can also say this way, that alpha is tan inverse of 3 by 4 or tan inverse of 0.75. Okay, but I will tell you that alpha is about 37 degrees. If you have a scientific calculator, okay, you can check this also in that. I will just show you myself also. 37 degrees होता है. Tan 37 is this. So don't worry about this alpha how it is coming. You can just leave the answer this way. This is fine. Yeah, I will teach you more about inverse function and all that. Don't worry. Okay. Okay, so for example, I'll just show you on, hopefully you can see, I'm using an Android app which is a real calculator or a scientific calculator. In this I'll show you that why tan 37 is equal to 4 by 3. Just give me a second, I'll show you this. Yeah, so you can see the calculator, right? So on this I will first type 37. Okay, so see I've typed 37. Now I will do tangent of it. Okay, so you can see that tan is this one here. Okay. So I'll press the tan and see the value you'll get. Yes. So 37 का tan आपको दिख रहा है? So 37 का tan when I calculate, see the value I'm getting 0.753 something. Okay, so this justifies that. So 37 degrees का tan is approximately 0.75. Right, so coming back here, this is the formula based method. Okay. Now I can equally easily justify this geometrically. I want to show this geometrically. It's not too difficult actually. जो हमने triangle law का derivation किया था, those steps will have to be just repeated. Okay. So this is my vector E. Let's say of 20 in this direction. Now in comparison, my vector B will be something like this. Let's say, suppose. So that is 60 root 2. That is my vector B at an angle of 45 degrees. Okay. So yes, out. So now in this, which is my resultant vector, this is A plus B. So मुझे ये निकालना है, ये resultant है, और मुझे ये angle निकालना है. So what I'll do here is just understand that in this triangle, in this triangle here, the one, just a moment, software is hanging up a bit, huh? So in this triangle, how much is this? ये अगर x है और ये अगर y है, so you can see that this is an isosceles right angle triangle. So this is very easy. This angle is 45. This is 60 root 2. This was y. This is x. So x is equal to y is equal to 60. So now you see the larger triangle. So in the larger triangle, this side is your r, and your full base and your perpendicular, they are such that this is 20 plus x. So that is becoming how much? 60 plus 20, that is 80. And this side is how much? It is just y, which is 60. So now your hypotenuse and this angle. So 100. Okay. And tan alpha is 60 upon 80, 3 by 4. So alpha is. Yes, Sushan, just hang on, okay? Let me finish the content of the lecture and I'll get back to you. हाँ, तो अल्फा यूजिंग ज्योमेट्री ऐसे ही होगा बेटा, मतलब tan alpha 3 by 4 this step. So both the things, the resultant's magnitude 100 as well as tan alpha 3 by 4, we are getting that geometrically. So as I said, this is only for my satisfaction. Formula से मुझे आंसर मिल गया है, just justifying कि आंसर क्यों है ऐसा. Got it now? Okay. Now the next thing we'll see, just take a few more minutes, okay? So the tricky thing for us now is going to be, what if theta is obtuse? Okay. Let's look at an example first. So suppose we have magnitude of E is, let us say, 20. Magnitude of B is, let us say, 40. Okay. But the angle between them, suppose theta is 120 degrees, angle of B with respect to E. Then how do we calculate magnitude of A plus B? And how do we come to know the direction of E plus B? Yes, just you can do that. But for the moment, I'll say one thing. Let's try this question first by geometrical method. Let's just try and construct the triangle and see what happens. Okay. So let's first try to construct the vector triangle for A plus B and see what we get. Maybe we'll just be able to solve by the triangle only. Yes, Tej, you can use those formulae. They are called the second quadrant formula for trigonometric functions. But I'm just saying, let's first just see what drawing the triangle will show us. You can do by that. So you can always use this kind of formula, that cos 120 will be minus of cos 60, which will be minus half, and sin 120 will be positive of sin 60. You might have done this in trigonometry, or you might not have done yet, doesn't matter. You will learn this in trigonometry. So one is you can use this formula, because in the second quadrant, the trigonometric formula we use is that cos of theta is minus of cos 180 minus theta, and sine of theta is positive of sine 180 minus theta. But I'm saying isko abhi just for the moment let it be. Okay, we'll come back to the formula. Let's try and solve this logically also and see what happens. Okay. So just try and construct the vector triangle and see if you get something interesting. Vector A अगर ऐसा है suppose, it's of magnitude 20 units. Now in comparison to this, where should I draw the vector B? It should be from A's direction. I have to turn by 120 degrees. Okay, so I have to turn from this direction by 120 degrees like this. So it should be in this sort of direction. So my theta, this is 120 degrees. This is my vector B and its magnitude is 40 units. Okay. So if that angle is that much, 120, then this interior angle, suppose beta, is how much? It is 60 degrees. Okay. Because my theta is that much. Because my theta is 120, so this angle. Now notice that cos 60 कितना होता है? Half होता है. Okay. और यहाँ पे that is nothing but A by B. Because A is 20 and B is 40. So that means these are the two sides of which type of triangle? Right angle triangle. So that means when I construct the resultant, which is going to be this, interestingly, the resultant is going to be at 90 degrees. So using this, okay, so this just happens to be a right angle triangle. Okay. Because these values are 20 and 40 and that angle is 120. It just so happens. So here I can just get away with simple logic that this is going to be correct 60, 30, 90 triangle and alpha is 90 degrees. Yes, I would. Now, admittedly, it will not always be so simple as I told you. Okay. But at least in this case, I have chosen an obtuse angle such that it's pretty easy to solve it just by constructing the triangle. Got it, people? This is clear? Okay. Now, if we want to use formula method, so I will get into the details of this formula next time in more, with more examples and all. But you can just write this for now. Okay. For the formula-based method, if theta is greater than 90, okay, obtuse angle, okay, then use the identity that cos of theta is minus cos 180 degrees minus theta and sine of theta is positive of sine 180 minus theta. Now ये क्यों होता है ऐसा, that also we'll understand very soon. In fact, vectors will help you understand these two formulae. But right now, just think of these as formulae. Okay? So these are just basically formulae for theta in second quadrant. Okay, second quadrant means when it is between 90 and 180. Okay, so let's use this. So substitute cos theta and sin theta using this. So in this particular problem, what will happen is cos 120 will be minus cos 60, as we just saw before. There will be minus half, and sin 120 will be positive of sin 60, which will be root 3 by 2. So now using this, we'd see in that previous formula, mod of a plus b, we have substitute kar do and see what we get. So substitute a as 20, b's magnitude as 40, okay, and theta is 120. So see what we'll get here. You will get 20 square plus 40 square plus 2 into 20 into 40 into minus half. Substitute the minus half over here. Right. So now calculate and see, you will get the same answer before. You get 20 root 3. You get 400 plus 1600 minus 800. Okay. That is square root of 1200. So that is and similarly tan alpha का formula भी आप use करके देखो क्या आता है. And tan alpha is b sin theta upon a plus b cos theta. So this was 40 into root 3 by 2 divided by a, which was 20, plus 40 into minus half, remember. So this becomes 20 root 3 divided by 0, divided by 20 minus 20. So this is division by 0, so this is undefined. So that is showing you that alpha is 90 degrees because tan 90 is undefined. Division by 0. So tan alpha is undefined, which justifies that alpha should be 90 degrees. So guys, my software is just getting hung up in between. Write this properly. So division by 0 है इसलिए undefined. This is (20 root 3) divided by 0. So the division by 0 means that it is an undefined quantity. Because tan 90 is undefined, na Kunal beta. Is it clear? Okay. Okay, so we will discuss more about this. Yeah, Diti, I'll send the notes already. We'll discuss more about this obtuse angles and all in the next lecture. And we'll also see, like, there is triangle law for sum of two vectors. Yes, I'll be sending you an assignment. So the first assignment sheet for vectors will be sent now, which you will have to complete or at least attempt all the questions before next week's class. And while attempting the homework questions, if you have any doubts and difficulty, you can message me directly on WhatsApp. You have my private number of WhatsApp on the group, that your regular group. So if you have any doubts, please send me an individual message. Okay, don't send it in the group because it will get very confusing with so many messages. Just send me the individual message if you have any. Okay? And make sure to revise today's lecture very carefully before you start the assignment problems. Okay. Now, couple of students who have joined newly, I think there are 2 or 3 students, right? Sushant, Sweta, is it? Just if you can stay back and just discuss with me. Yes, assignment discussion will happen in the next lecture. I will send you the assignment. So make sure you attempt all the questions before the next lecture so that you can discuss it with me. Okay. So those students who have attended the first lecture, just stay back for 2 minutes. I need to discuss some things with you. Yes, the others can be better. No problem. Okay. Class is over. Just only the students who have joined recently.